This is the second video of homework 4, and this question is 1.822. This question asks us to pair up the frequency response diagram with the zero pole diagrams. So we're going to discuss the zero pole diagrams one by one. The first diagram is this one. For the first one, we can directly, because we got one pole and 1 0, we can directly get big H, which equals d minus 1. Likely, the pole is 0.7, so we can get this and get the big H in frequency domain. And when omega equals 0, we can get that big H equals 0, and when omega equals pi, we can get that H is likely to be 1.2. So in the frequency domain, in frequency response diagrams, we can find that R7 fulfills our requirements when the omega equals 0 and when it equals pi. So the diagram 1, for diagram 1 we can choose response 7, and for diagram 2, here's the diagram 2 with a double 0 and 2 complex poles. So for this question, we can get a resonant peak. A resonant peak happens only when the system has complex holes. So we have a complex host here, 2 complex hosts. The frequency responses 1, 2, 4, 5 may have the resonant peaks. Here, this one, these two, so 1, 2, 4, 5 might be the answer, and then we can get the big H equals this style, and for R we set it to be 0.8 because it might be this, looks like. And then we can get that theta equals 0.4 pi, also likely. Then the answer can be 1 or 5. So for 1 or 5, we cannot decide yet. We draw the zero pole diagram here. This is a diagram 2, this is a diagram 5, because they are similar. 2 and 5. The difference is only on the poles. That's for this the R is shorter, and for this the R is longer. And then we can get that for diagram 2, this A multiplied the model of AB divided by CD should be larger than that one for diagram 5. So we can match diagram 2 to R5 and diagram 5 to R1. This is R5 and this is R1. The frequency is larger for R5. Then for diagram 3, also it has two complex poles. So the resonant peak here happens at a lower frequency, and so we can choose R4. It'll be simpler. All right, and for diagram 4, 1 0 and 1 pole. So here we write the big H of Z in this style and get the H in frequency domain. And when omega equals pi, we can get that the H becomes 0, so we match R6 to D4. Here's R6. When omega equals pi, the response becomes 0. And then for diagram 7 and 8, have a look at them. The only difference happens on here, the pole. So this pole is the real part is smaller, but this one is larger. And we can do these two together, get the big H, and then do the Fourier transform. And when omega equals 0, the H7 becomes 2.5 and H8 becomes 5. So this is smaller and this is bigger. So we can match R3 and R8 and see the frequency differences. This one is bigger. To diagram 7 and diagram 8 individually. And the last one is D6. Here's a diagram, 2 zeros and 2 poles. You can write down the big H with the position of poles and the zeros, and then the Fourier transform becomes this kind of things, and we can get it when omega equals 0, this H equals 0, because here it's 0, 1 minus 1 is 0. So this system has a resonant peak at a low frequency, and only R2 remains. So we choose R2 here. So this question has been solved.